Hello, I'm Urania, the Greek muse of astronomy, and I'd like to help you with your revision of the astrophysics option in the A-level physics specification. You may also find the following book useful: The A-level Astrophysics Workbook, by Dr. G.K. Fox, exclusively available in the Kindle store. It also happens to have a picture of me on the front. In this video I will review the diffraction pattern for a single star. In this video, we can see the diffraction pattern of a laser light passing through a webcam. It produces a similar diffraction pattern that would be seen for starlight diffracting through a telescope. To recall how to draw a labeled diffraction pattern for a single star is a map from memory technique. When drawing the pattern, it is easier to start by drawing how the intensity of the light varies with angular distance. First, we mark out the axis. The y-axis is relative intensity, and the x-axis is angular distance from the center of the star. On the x-axis, we mark an equally spaced scale in both directions. We can now draw the intensity graph. Remember, the graph is symmetrical about the y-axis. We first draw the central peak, called the central maximum. It is the brightest of the maxima, containing about 95% of the total light. The principal maxima has a width twice that of the other maxima. I usually start on the x-axis, at the first marker to the left of the center, and draw a steep, triangle-like curve. I usually draw the next two maxima and minima. The two subsidiary maxima are drawn just one interval long. Notice also that, the further the maxima are from the center, the smaller the peaks become. After drawing the two secondary peaks on one side, I copy the curve to be mirror symmetrical about the y-axis. Once the graph has been drawn, the visual diffraction pattern can be attempted. The pattern should look similar to a bullseye target, being circularly symmetrical about the central point. Given that you would normally be drawing this with black ink, the diagram can become problematic, inasmuch that black usually indicates the absence of light, and not the light from the star. To overcome this issue, draw black rings the same diameter as the minima are drawn on the graph, and leave the white of the paper to represent the white light from the star. In my diagram I have chosen a star that appears red, and I have drawn the intensity variation and diffraction pattern in red also. Once the diagram has been drawn, it can then be labeled. The central bright disk, containing about 95% of the total light, is called the airy disk. Thank you for watching.